We've just estimated by multiplying the average altitude by the width of this force versus position trapezoid, the area under the force versus distance curve. Realizing that the force versus distance curve has a curvature like this, we say that the actual area under the curve is going to be somewhat less than the 2.7 billion joules, or 2.7 times 10 to the 9th, or 2.7 gigajoules. And just as a ballpark estimate, let's say that this is about 2 times 10 to the 9th joules, that the area under this curve is 2 times 10 to the 9th joules. We can actually find that area, of course, using calculus by integrating the function. If you know calculus, you can find that very easily. We could extend our calculations out to another Earth radius, from 1 to 2 Earth radii. Remember, we get the delta W approximately equal to 2.7 times 10 to the 9th joules, or our more accurate estimate, hopefully, of 2 times 10 to the 9th joules. Over the next trapezoid, we're going to go out to 3 times the Earth radius. At 3 times the Earth's radius, the gravitational influence will be spread out over 9 times the area that it was here. Now remember, here the acceleration of gravity is 9.8 meters per second squared. When we spread it out over 9 times the area, it'll be 1/9 of that. So we take 1/9 of 9.8 meters per second squared, which is about 1.1 meter per second squared, multiply it by our 75 kilograms, and we end up with something on the order of 76 newtons. If we average the 76 newtons and the 170 newtons, we get an estimate of maybe 0.8 times 10 to the 9th joules. You should do that yourself and see if I've made a mistake there. I might well have. I haven't checked that. It hasn't been validated. It's probably close, but it might be 0.7, it might be 0.9. Okay? We add these up and we get some result. Now we could, of course, continue that, okay, from 1 to 2 Earth radii. We're estimating around 2 gigajoules. Now up here we said 2.7, but that was a trapezoidal estimate without any correction. So if we accept my correction, which I think is maybe a little bit of an overcorrection, we're going to say 2 gigajoules here. Then here, we estimated 0.8 gigajoules, taking the curvature into account. Maybe that's 0.7. Over the next interval, maybe it's 0.3, then maybe 0.2, maybe 0.1. You can make your own estimates over intervals from the radius of the Earth twice to 3 times, 4 times, 5 times, 6 times the radius of the Earth. I made a stab here. I said that I think that the total area under all these is going to be less than the total area under just this one. And that is even if we continue these all the way out to infinity. We continue doing this all the way out to infinity, they're never going to add up to more than this one. And if they do, it won't be much more. So I estimated that the total area we have, even if we went to infinity, is going to be less than 4 gigajoules with a question mark. I feel fairly certain that that area is going to be less than 5 gigajoules, which is what I said when I made this estimate. I wasn't sure about the 4. I felt pretty sure about the 5. I'd lay a small bet on the 4 and a big bet on the 5.